Does your boat have a squishy deck? Does it feel like you're walking on concrete or more like a old used trampoline? Maybe you've got teak decks with screws from the top, and unfortunately it might just be a matter of time. In this video we're looking at 8 core materials that could get your deck back into tip-top shape. Let's see if we can pick a winner. Hi, my name is John, and if you're new to this channel, we're doing a full restoration of this old boat, a Liberty 458. Like many of the boats built in Taiwan in the 70s, 80s, and 90s, she came with an original teak deck that was screwed down from the top with hundreds, over 1,000 screws. Now, 34 years later, it doesn't seem like such a good idea to screw these decks down from the top like that. And there are many leaks that have compromised this core. The sad reality is that after many decades of use, even a well-kept teak deck will have water in it by now. With thousands of leak points for water to get in, it'll find its way and it just never comes out. So eventually you'll find yourself doing what I'm doing, cutting it all out. Many of these old boats have balsa or plywood core decks, possibly a combination of the two. Either case, if you've been getting water inside the fiberglass core, it's not going to be looking too good and you're going to need to do some repairs. Now, if you're a lucky person that has a foam core, or maybe you never had a teak deck installed to begin with, you might be able to skip the rest of this video. But for the rest of us, stick around. We're going to look at some different coring options that you have, and let's start with why even have a core to begin with. The I-beam analogy really does work the best. So here we have a piece of 1/8 inch steel flat bar, and you can see here that it's pretty flexible. And when we put this on the bench at home and measure the deflection, you see there's quite a lot of deflection there. A piece of 1/8 inch angle iron, and this is sort of like 1/4 of an I-beam. You see here that this does not bend at all. I can't feel it bending at all. And when we measure it on the bench, you see just the smallest amount of deflection is measured when we loaded it up with that almost 10 pounds. So if you think about the core of your boat like an I-beam, and the bottom skin is like one of the flanges, the top skin is the top flange, and then the core is basically like the web of the I-beam. Except instead of being an I-beam that it runs in one direction, the deck of the boat is like a 360-degree I-beam. Think about it that way. So if you think about your deck and someone is standing on it, the bottom skin is going to be in tension and the top skin is going to be in compression, and then everything in the middle is experiencing what we call shear forces. And so this foam book kind of helps to show you what I mean. So if you think about top skin, bottom skin, and this movement here is sort of like the shear forces that you're trying to resist with a good core material. And if you look at that line here that we do, that's a straight line, you can see that when we bend this book, that line starts to kind of bend and move, even though the pages are still together. When I clamp this down, hold it really tight, and then I apply a bending force to it, you see there the top starts to buckle, the bottom is pulled tight, and everything in the middle is resisting that shear. So that's what your sandwich core is doing, is it's resisting those shear forces. So the chord construction really does allow for a much stiffer deck to result with not too much weight penalty. We are going to take a look at 8 different core materials, and I have 9 specific mechanical properties that I want to compare with each of these materials to try and help us make a good informed decision about which one might make sense in our application. This is just my list, and these are my interpretations of the published numbers that these companies put out on their websites. I haven't worked extensively with all of these materials, but I can say that all of them are used regularly in fiberglass core construction, so any of them should work. Maybe this will help you decide which one is the best in your particular application, given the different properties. Sound good? Let's get into it. Okay, the first and maybe the most important material property for your core material is going to be shear strength. That's one we've already talked about. Let's keep moving. Number 2 is compression strength, and this is going to be the material's ability to resist that squeezing force. So this is where you're like bolting fittings up into the deck. We're looking for materials that have pretty good compression strength, and now you might want increased compression strength for like under a high loaded fitting or something like that. And then keep in mind also that compression strength will impart onto the impact resistance of the deck, but you can also boost that by adding more top skin thickness. So you don't want to put a big dent in your deck the first time you fumble your spinnaker pole, so let's make sure that we've got lots of that. Number 3, this is one that I've sort of made up, and it's what I'm calling shear strength to weight ratio. And from the talks I've had with some naval architects, it's not really a thing, but it does make some sense to me, and it is an interesting thing just to look at because it's essentially shear efficiency when you're trying to build a light deck for your boat, it's something that you might want to consider, is how much shear strength are you getting for its given weight. So that's one that you can look at, take it or leave it. I just made it up, but it's interesting. Number 4 is just density, or the weight of the material. You're going to definitely need to make sure you're monitoring that. If you're taking out balsa, for example, you might not want to put back in a heavier material. You want to make sure that your deck overall is at about the same or less than the original weight. That would be my advice. Number 5 is water resistance. This is especially important to me as I'm removing my deck core because it is saturated with water and has completely failed. Now, it should be said that the wood isn't really necessarily a bad core material. It's that the building practices of the time have failed, and so there's a lot of water in the deck. Now, all that said though, if the core material was waterproof or much more resistive to water damage, then I probably wouldn't be doing this job right now. So that's something that you want to consider. Maybe you want to make sure the material you're putting back in your deck has a much higher water resistance. Number 6 is insulation, and this might be a secondary benefit if you're changing from one material of your core to another. You might find that the new one has better insulation properties, so that might be a nice little side benefit. It's probably not going to be a huge difference, but it's something to think about. 7 is workability, and this is really just how easy is it going to be to work with the material, to fit and finish it into the different areas of the deck. So this is going to be what kind of tools can you use, hand tools, power tools, does it cut well, can you sand it, plane it, all those things. And then does it work well with standard resins and techniques for installation. 8 is going to be cost. Pricing is important and it varies wildly from these different materials, anywhere from around $2 per square foot up to well over 100. So that's going to be something to think about. Lastly, 9 is availability, and this is really just how much work are you going to need to do to get this material to your project. Some of these materials are only available from very certain suppliers, others are much more common, but I will warn you that you will not find any of these at your local big box store or hardware store. If you think you have, please, please, please double, triple check, because I really doubt that they're selling anything appropriate for a boat deck core at those places, so be careful. Now, something that I didn't account for but are interesting to think about, there's 2. One would be screw holding. Is it able to hold a screw? And that might be something that you want to consider if you're installing things, hopefully from the inside of the boat and not from the outside, because we don't want to be doing that again. But that's something you could consider. And a viewer of one of my other videos mentioned that you might want to consider insect resistance, and this is something to think about. In the Pacific Northwest, we don't really have problems with wood destroying insects in boats, but that might be something where you live and you want to think about that. So maybe you want to stay away from woods even for that reason, just to make sure that your deck core is going to be completely insect proof. Okay, so those are the 9 options. Now let's take a look at the individual materials. Okay, so the first up on our list is good old-fashioned plywood. This is just a sample of some standard 1/2-inch plywood. I will let you know that this is not marine grade plywood that I'm showing you, but it will look very similar. Now, I've already mentioned this, it's imperative that if you're using plywood that you get marine grade plywood. This is not the green stuff, the pressure treated plywood that you get at Home Depot, but this is BS 1088 or BS 6566 marine grade plywood. Some of the trade names are Hydrotech or Aquatech, and these are going to be available from maybe fine specialty plywood suppliers or boat building suppliers. This is not going to be at your big box store. Plywood is going to have great strength and compression characteristics because it's mainly solid wood. The weight of plywood is about 40 pounds per cubic foot, so it's on the heavier end. It is the second heaviest material on this list. Now, the shear to weight ratio is respectable. It's in the middle of the pack. Water resistance is not great. It's probably one of the lowest on this list because it has all the grain running in the plane. That's going to allow water to move around very easily because it travels along the cells of the wood. And since the cells are oriented 90 degrees to each other, water has paths to go just about anywhere it wants to go. You could try to seal up all the edges of the plywood before installing it. That's going to add a lot of time to your installation, but it's something that you could think about. Again, plywood is going to be a great option as long as you make sure that there are no penetrations in the deck that could allow water in. But, you know, water likes to go where it likes to go. So, okay, for insulation, plywood is on the second to lowest. Again, it is about R1 per inch. And for reference, your fiberglass insulation at home is going to be around R4 per inch. So wood is not a good insulator. Now for workability, we're going to give plywood probably the highest marks for workability, or really close to it, because it's very familiar. You can use any of your standard tools to cut this wood. You can sand it, you can shape it, you can router it, you can plane it. You can do pretty much whatever you want with it, and it's not going to dull your tools significantly because it's wood. It's what the tools are made to work with. For cost, plywood, marine grade plywood, BS 1088, is currently selling in my area for around $4.70 per square foot. And it's going to be available at a number of local fine quality wood suppliers or boat supply shops. Now, in North America, marine grade plywood is going to be quite common. My understanding is that overseas in Europe, maybe other parts of the world, not as common. You can let me know in the comments what is common in your area, but I'm curious to know. But around here, plywood is fairly common, so this is a reasonable option to go with. I would be looking at plywood if I wanted something with high compression and shear properties, maybe under loaded fittings especially. I might do this material in certain places and not in others. I would want to make sure that I'm getting it coated as much as I can so I avoid any water intrusion difficulties. But it's a good material. It's easy to work with, so it's a reasonable choice. Okay, number 2 on the list, and the only other wood product that we're looking at, is balsa. And this is going to be a great choice as long as you can keep it dry. I have areas on my boat that contain balsa, and I'm finding that some areas are deteriorated to the point that they are like used coffee grounds, while other areas appear to be totally intact but are saturated. They're still holding very strongly to the fiberglass, even though they are essentially saturated with water. So it's pretty interesting stuff. You'll usually find that it's attached to these scrim sheets when you buy it. It comes in these small-ish panels. It's pre-cut, so it does conform to curves very well. Let's break one little piece off here so we can look at it. With the balsa, the grain is going to be oriented up and down, and that's really important. That's what gives it its extra compression strength and also the shear, and it allows the resin to travel up and down the cells of the wood and form really good bonds between the top skin and the bottom skin. So balsa, again, great material if you can keep it dry. Balsa has almost twice as much shear strength as the plywood does. That's probably because the cells are oriented up and down and there's no slip planes like plywood does have. Plywood's really relying on that glue. The compression strength is less than plywood, but it's still very good. It's near the top of the list. And with the density being as low as it is, it depends, because it is an organic material, the weight can vary. I've been looking at between 6 to 9 pounds per cubic foot, and that puts the shear strength to weight ratio quite high. It's near the top of the list. It's, I think, the second highest. Now, water is going to be an issue with balsa, as we've mentioned. It is susceptible to rot. It doesn't migrate as easily as the plywood since the cells are all up and down. The water can't move around as easily, but it still does get in there, as we've seen, and it will rot the wood. And the other thing about balsa is that it holds 600% at full saturation. So if you have a balsa deck that is completely full of water, you have a lot of water in your boat and your deck is very heavy. For insulation, balsa is about twice as good as the plywood, but still half of a lot of the other materials at about R2 per inch. So don't be looking at balsa if insulation is high on your list. For workability, balsa finishes just behind plywood. It works really well. It sands well, and it cuts easily and all of that. But with it being attached to these scrim sheets with lots of blocks all in a line, and you need to be mindful of that when you're cutting, especially with any sort of power tools. So that's something to think about. But otherwise, it works really well. You'll also need to consider that it has a lot of resin uptake. You're going to need to saturate this with resin well before you start to lay it in, because it's going to soak into all those cells. You don't want to get a dry joint. So that's something to think about too, and that does hurt the workability a little bit, is that extra step. Now, balsa prices out currently at around $7.50 per square foot, so it's a reasonable choice. It's going to be a little harder to find than the plywood, because you won't probably find this at specialty wood suppliers. You're really only going to find this with fiberglass suppliers or boat building suppliers, but it is readily available, and you can find it online. I'd be looking at balsa if I was really interested in very high shear strength to weight ratio, but you do need to be considering that you're probably not going to want to use this under heavily loaded fittings, and there is also that water issue. If I had a balsa cord deck and I did not have a problem with water, I would be very happy for one, and then I would not be making this video right now. I would be busy making sure that all of my deck penetrations have been overboard and epoxy plugged. And we'll put a link up here to a video to see how to do that in case you're not familiar. So if you're fortunate to have a dry balsa deck, then you're going to want to keep it that way. Check out that video. Number 3 on the list is G10. So this is a compressed fiberglass and epoxy panel. These are specialty made and they are very, very strong. The mechanical properties are off the charts for these, but they're heavy and they're expensive. These can be machined, they can be drilled and tapped to accept machine threads. You can actually, given that the threads are deep enough, you'll probably break the bolt before you break the threads in the G10. They're that strong. So they have the highest height by many factors. They have the highest shear and compression strength numbers. In fact, even at the density of over 100 pounds per square foot, I think, yeah, it's 112 pounds per square foot, and this is still has the best, by a lot, the best shear strength to weight ratio. Now that is what we would call an outlier, because if you tried to core your boat with G10, you would probably have a little problem where as soon as you untie the lines at the dock, you start floating upside down. The density is high. We said 112 pounds per cubic foot. Water resistance is about as good as it gets. There's really nowhere for water to go here. Insulation is poor. It's about R 1/2 or 1/2 R. So it is the bottom of the list for insulation, acoustic and thermal insulation. Workability is good, but it's not the best. Because it is so dense and it's made of fiberglass, it's going to be somewhat difficult to machine and it is going to dull your tools quite rapidly. It's also because it is so rigid, if you were installing it in any kind of curved panel, you would have to make a lot of relief cuts, which would sacrifice a lot of the structural properties. Price is going to set you back a little bit and it might blow your hair back as well. It's $75 to $150 per square foot is the typical retail cost of G10 panels. So that's something to consider. And then it's only going to be available from specialty retailers. You can find this on like McMaster-Carr, but other boat builders, sometimes they have products like this, but you're not going to find this at a hardware store. So amazing stuff. It's incredible. There's really nothing else quite like it. It's going to be great under heavily loaded fittings like the staysail fitting, the stem head fitting, under winch pads, windlasses, things like that. So that's where I'll be looking for a material like this, is in those kinds of applications. Number 4 on the list is an interesting material. This is called Nydaplast 8. And this is a structural honeycomb. It's a polypropylene honeycomb. Here's one that I've cut open so you can see the inside. So you can get an idea of the little cells there. But it's a polypropylene honeycomb. The upper and lower skins are thermally bonded, so there's no way for water to get in unless there's a puncture. All of the internal cells are under a vacuum, which is interesting. And then it has these sort of scrim sheets that are fused to it, or it's a polyester or something sheet that's fused to it. Now I'd be interested to know what the peel strength is on this, but that's not a value that's published really for any of the materials. Shear strength and compression strength for Nydaplast are on the lowest end of this list. I think because they are plastic, even though they're in sort of in column, it was the lowest rated for those two values. But it's the lightest material in the bunch at 3 pounds per cubic foot. So the strength to, or the shear strength to weight ratio still ends up respectably in the middle. Water resistance with this panel is going to be good since they are all sealed, but if there were to be some sort of puncture, water will fill that cell entirely. It could, in theory, hold 100% water, but that would be a really unlikely failure. Water resistance with the Nydaplast panel is going to be respectable. It's somewhere in the middle. Now, because they put these together with the top and bottom sheets and they fuse them under a vacuum, that means that this panel has excellent insulation properties. It comes out at around R4, which is about as good as you're going to get. And so insulation for acoustics and thermal properties should be really good with this panel. Workability is going to be very good. It's super easy to cut because it is rather soft. You can cut it with a knife, which is the first time we've been able to say that, and most other machine tools will work fine. You know, you're not going to be able to change the thickness at all. You couldn't sand this, so that's something to think about as well. If you're looking for off sizes, this might not work well for you. Nydaplast 8 comes in as the most affordable core material on the list at $2.40 a square foot. That's really good. Now, the only downside to that is that it has very limited distribution. So you're going to have to find a supplier that can get it to you, and you're going to probably be looking at some shipping cost unless you happen to live in the local area. But it is a very interesting material overall. So, you know, if I was looking for the lightest material possible, if I was a racer per se, this is probably what I'd be going with. Number 5 on the list is the black sheep of the family, quite literally. This is a Coosa panel, and it is a polyurethane foam. What's interesting about this is that it is a foam construction with, you can sort of see here, a layer of fiberglass on each end. So there's like a woven roving on the ends, and then there's sort of this matte, random strand mat on the ends, and then the center core is more just the foam. So if you're using Coosa as the core material for your fiberglass sandwich, you essentially have a sandwich inside of a sandwich, and that sounds delicious. For shear strength, G10 comes in above any of the wood products on the list and only second to G10. It's got really good shear strength. The compression strength is also high. It is not as high as the wood materials. It's about half, but it's still 4 times what any of the other materials that were on our list are capable of in compression. So it is a good material under heavily loaded fittings. Coosa is dense. It comes in at 26 pounds per cubic foot, which puts it on the low end of the shear strength to density ratio. Water absorption is not going to be an issue with Coosa. They advertise it as being totally fine installed as is without a fiberglass coating. The insulation value is going to land it somewhere in the middle. It's about R2.3 per inch. So it's not on the high end for insulation values. Workability is good. It's fine. You can cut it with any standard tool. It does create a lot of dust with the extra fiberglass embedded into it. It is going to dull your tools more than some of the other foams. It's also quite rigid, so if you need to have it conform to a shape or a crown, you are going to need to make some relief cuts in it to get it to bend nicely for you. At $11, almost $12 per square foot, the Coosa panel is somewhat expensive. Now, they have a vast array of dealers and retailers on their website that you can look up, so you should be able to find a place close to you that can sell you these panels. And so you might not need to pay for shipping, which is going to be advantageous. Overall, it's an interesting panel. There's really nothing else quite like it. It is going to be great under heavily loaded fittings. It's commonly used in transom replacements holding large outboard motors, so you know that this can really hold up to that kind of abuse. With its density being what it is, it's probably not going to get a lot of real estate on my project, but I am looking at it for high load fitting areas. I find it's an interesting panel. Next up on the list is what is called Kerdyn or Kerdyn. I don't know how you say it. I should have asked. This is a recycled pop bottle panel, believe it or not. This is from a company called Gruit. So the shear and compression properties for this foam are on the lower end. They are still totally appropriate for the application, but they are not by any means on the high end of this list. For water absorption, you should be just fine, and insulation value is not published. But seeing as how, you know, if you have a North Face polar fleece or something like that, it's essentially made out of the same material. So I would be very surprised if the insulation value wasn't somewhere between R3 and R4. Workability with the Kerdyn panel will be good. You can cut it with a knife or other machine tools. So it works really well and works with all known resin systems. I don't have an exact figure on the cost, but it is supposed to compete with other 6-pound foams, so I think it'll be in line with those. The availability might be an issue. Because it is a somewhat newer product, you might have a harder time finding this, but if you contact Gruit, I'm sure they can find some for you. It's an interesting panel. If you are looking for a middle of the road for mechanical properties and you are especially fond of the environmental impact of this panel, that being that you're essentially pulling some of that plastic out of the ocean and recycling it and putting it back on the ocean in a sense, then this might be a panel that you're interested in procuring for your project. So something to think about. This is the Kerdyn from Gruit. All right, next up on the list is from a company that started the revolution away from wood core materials in the 70s. They are called Diab, and this is their Divinycell H100 panel. This is their 6-pound foam. They are a huge company. They operate all around the world, and so you'll be well supported if you go with a product like this. They have a production facility for these foams in Texas, so it's made in America. For compression strength and shear strength, the numbers on this product are the highest of the pure foam variants of those three. Now it is going to be less than the wood, the plywoods, and the Coosa for compression and shear strength, but at 6.3 pounds per cubic foot, it's second to Balsa, third if you count the G10, but we already talked about that. So it has really good shear strength to weight ratio. Water absorption is not going to be an issue with the panel because it is a closed cell foam, so water can't really go too far into here. And workability is excellent. All standard hand tools and machine tools will work with this foam. You can sand it, you can run it through a thickness planer. It also works great with all resins, epoxy and polyester. And since it can take a gentle curve, you should be able to adhere it to most shapes. Apparently you can also form it with heat if you're doing a complex shape, but that's probably not a problem for your deck. For cost, you can expect to pay probably $7 to $9 or $10 per square foot for this panel, depending on where you source it from. You might be able to find this locally at a fiberglass supply house or a boat building supplier. If not, Diab will probably sell to you directly. So you can contact them, tell them what you need, and get a hold of one of these panels. This is a great material. You know, if you're looking for waterproof core material that has excellent workability, great strength to weight ratio, somewhere in the middle for cost, then this is probably a good option for you. So something to think about. Okay, and the last one on my list is again from Gruit, and it is another pure foam material. I don't have a sample for it, so I can't show it to you, but it would look very similar to the one that I just showed you from Divinycell. It is called Corecell, and it is not a PET foam or a PVC foam. It is what they call a SAN, S-A-N polymer. And this is made a little bit different than some of the other foam products in that it's made in giant blocks in Canada, and then it has to bake and cure at temperature for a very long time. Once the material has sort of cooked and all of the mechanical properties have been baked into it, then they slice it up into the appropriate thickness for whoever is ordering it. So it's a very interesting panel. It is one of the newer technologies for foam core material. And if you're a viewer of my channel, you'll remember that when I went to see Bob Perry for my first talk with him where I talked about my refit, and we'll put a link to that video here if you're interested to see what we talked about, he was quick to recommend Corecell for coring material. The mechanical properties for the Corecell are very good. They come in just slightly below the Divinycell for compression strength and shear strength. It's a little heavier panel, so the shear strength to weight ratio is also a little bit lower, but there is reported to be an extra toughness in these panels, and it's hard to see it in the numbers on their own, and I don't have the experience to be able to verify that, but that's sort of what you hear, is that it's a very tough panel and it can take a lot of pounding and abuse, and on a sailboat, that's a good thing. Corecell comes in at 6.7 pounds per cubic foot, so it is a little heavier than some of the other 6-pound foams, and the insulation value is slightly lower at 3.6, but still all very respectable numbers. Water absorption is going to be no problem with this panel, and workability, I assume, is good, just like it is with some of the other foams. So you should expect to be able to use any of the tools you need to install it, and it should take resin from epoxy to polyester just fine. For price, you can expect to pay between $9 to $12 per square foot based on my research, and you will probably have a slightly harder time obtaining this material because it is one of the newer offerings on the market. It's sort of the high-tech foam right now, so you might have to wait a bit if you're interested in getting Corecell, but if you're interested in a high-tech foam, the latest in technology in foam core sandwich construction with good mechanical properties, then Corecell is a very good choice. So what material is best? Well, that's really going to be a subjective question that you're going to need to answer for yourself. You know, if you're a traditionalist, you might want to just stick with wood, and that's fine as long as you keep it sealed up really, really well. If you're a racer and you want the lightest possible construction, then it's going to be hard to argue with Nydaplast. If you want something that's super tough and is completely waterproof, then Coosa might be a good example, but you can't be too concerned about weight. You know, and all of the foam cores are going to be excellent choices, especially if you're replacing an old wooden core. If you just have small localized repairs to do in, say, a balsa deck, you might even want to just buy a few small panels of balsa and sort of patch those in, and that would be fine, again, if you're keeping things dry. Now, if you're doing a full wholesale replacement like I am, then you can kind of go clean sheet and you can start with a whole new material. And I think it's important to note that you don't need to be an engineer for any of this. Any of these products, if you call the company that manufactures them, they should be able to tell you exactly what you need for your deck. If you contact them with a spec for your deck, thicknesses, drawings, maybe even where the bulkheads are located, they're going to be able to verify that you are picking the right foam for your application. So take advantage of those suppliers and their knowledge when you're doing a job like this. So what am I going to choose? Well, you're just going to have to wait and see. Now, if you're a member of the Patreon group for the Living for Sale channel, then you already know, because Patreons do get intermittent updates and behind the scenes information, so they'll already see that. And I will upload all of my research that I've done here to the Patreon group if you're interested in joining that. It does help a lot with the creation of these videos, and it's very much appreciated. If you've enjoyed today's video and it's been helpful for you, maybe in making some decisions for your core or entertaining in any way, I would love it if you'd hit that like button. If you're interested to see the refit of this old boat from the beginning and follow along with that, I'll put a playlist over here. And if you are interested in subscribing to this channel for more of these videos, then you can hit the button right there. See you next time. Now, since the plywood has all of its grain running in the plane, that's fun.